Hello, friends. I'm Ashish Darbari, founder and CEO of Aximize. And to our new listeners, welcome. To our old ones, welcome back. I hope you enjoyed our last week's podcast in an informal chat with Simon Davidman. This week, I want to talk about 10 reasons why you should use formal verification. So, in this podcast, I would like to focus on the economics of why formal verification is important, necessary, and why you should consider it as an important ingredient in your verification technology recipe set. So, we need to understand what are the different verification related costs in a typical SOC design verification program. And in my view, cost is not just the expenditure incurred adopting a new verification technology in its early days by just making an initial investment in tools and training or even deploying it, but it should also be measured by how long the technology takes to use in practice, what kind of bugs it helps to catch, how it affects debug, and finally, how it contributes to signing off verification with confidence. Cost of finding bugs and cost of missed bugs are both important to consider. So as much as we are focused on have we found the last bug in the chip, we should also ask the question, what bugs, if any, are getting missed and what would be the impact? Now, with all that in mind, what I would like to do today is to summarize my 10 main cost points along with the reasons why you should adopt formal to control these costs and be successful. So the idea here is not to just make the case of saving money, but also want to highlight that as much as you're actually saving money, you're also obtaining efficiency in verification, meaning with lesser cost, you're obtaining a higher ROI. The idea of emphasizing this podcast on the cost side of this is because I often hear people complaining that formal verification is quite expensive to adopt. So let's start my very first one, tools and support, which is a common complaint by a lot of people that tools are expensive. So how much do the tools cost? How easy is it to use them? What is the support cost if one ever needs it? What is the cost of maintaining the tools, their different patches, and so on? What is required to ensure consistency in their use across the organization? These are all important, relevant questions that one asks if they are going to talk about tools and support. So while it is true that formal tools do cost more than their simulation counterparts, they also cost a lot less than emulators. Now, you would have noted from my discussion with Laura Rizzardi in one of my previous podcasts that emulation is a necessity for verification. So I'm not suggesting you don't do emulation, okay, or simulation for that matter. I mean, going back to the chat with Simon, we need simulation, we need emulation, and we need formal. The initial cost of investment in formal tools quickly gets repaid when trained engineers deploying good methodologies start finding bugs earlier in the design cycle and are able to exhaustively prove the conclusive absence of bugs. This is not possible with either simulation or emulation, so in a way, formal is very complementary. Using multiple simulator licenses, right? Because that's what people usually do in most projects. You're not just going to use one license. To achieve better throughput, for example, for test rate, that can offset the costs of, thinking that you have only one simulator, so it might be cheaper, but now you have to buy 4 or 5 different licenses or even run 10 at a time. So this cost quickly accelerates in the simulation space. Now, if you compare this against a formal verification tool license cost of finding the same issues, and even more due to the way formal technology works, notwithstanding the fact that you can also build exhaustive proofs, you would notice that the cost of just buying tools, like for like comparison, and how many simulator licenses you need to become productive versus how many formal licenses you need, you would notice that they would even out very quickly. And this is mainly because whereas constrained random simulation takes this randomized approach, of course, that we all know it requires a significant initial investment in developing the test bench and running the same test harness with different seeds in parallel. Formal can explode the state space exhaustively without requiring any stimulus or seed because of the way formal algorithms work, breadth first search, systematic exploration of state space. So you would find that actually you can get your corner case bugs much more quickly with formal and with much fewer licenses. Let's talk about training. How much does it cost for each employee? How long does it take? When will it start to pay off? Now, most good training programs, and I would count our own training program as amongst the good training programs out there, we require that the student should be ready to start working on the project after the training. Of course, the assumption is that the student is sitting in the training program, following all the description, discussion, doing all the labs, so they are actually ready. I mean, if you come to our training program and don't do labs, for example, the training program isn't going to be very effective for you. So, assuming you've gone through the mechanics of going through the training program, the adoption of formal on projects isn't that long. So, scoping out what can be done with the trained resource over a staggered period of 6 weeks, 1 quarter, and 6 months, that's a good rough plan, could give you a very good insight about whether or not the training is effective. So, if you're not seeing any return on your investment after 6 months, but this has provided you made that investment in its sincerity, the training probably hasn't been deployed properly, and you must look at the reasons why. But if you have derived enough quality results from formal in 6 months, you should have already recovered your initial investment. So from this point onwards, the ROI will simply continue to grow. So I'm not saying that it takes 6 months to even out the cost that you invest in tools and training. What I'm saying is you can give it at least 6 months. Most of the time, the returns will start to appear quite quickly, especially if the methodology is correctly deployed. So let me talk about this. A good training methodology has been the major reason why formal verification hasn't been successfully deployed. Now, if you do get good training and if it is methodology oriented, modular, tool agnostic, you are going to get good results. And you should also compare the cost of these trainings versus the cost of training people in simulation-based technologies, not just the initial cost, but also how much long it takes to come out of the training before you become productive. Let's talk about methodology, right? Factor number 3. So has it been developed thoughtfully? How's it promoted and adopted across the organization? Do you have a mismatch of different competing flows and methodologies, or do you have one consistent methodology built for the right reason and not because of any political reasons, shall I say? So just coming back on the methodology side, so has it been developed thoughtfully? How is it promoted and adopted across the organization? And can every vendor's tools be applied within it? So these are the questions that you would like to consider when you talk about methodology. An investment needs to be made in effort, time, and money, right? So to ensure that any methodology is adopted properly and consistently within an organization, the methodology should consider the overall scope of verification and should look to solve the real problems in verification, not just focus on exploiting automated features within your tools. So your methodology should be completely vendor agnostic, and your training providers should provide instruction that works seamlessly across all tools. I'm happy to say the training we provide is completely vendor agnostic, and we are focusing on problem solving as a way to teach people how to deploy formal in practice. Let's talk about tool deployment. What does each license cost? What is the tool's runtime? What is the cost of the required compute cluster? These are again questions that are going to affect the choice of how many tools are going to be able to run successfully. What is the tool's runtime going to give you in return for your investment? So from my experience, if a well-trained engineering team is using its tools properly, they not only find more bugs, but also optimize the runtimes of compute clusters effectively. This in turn means they require fewer licenses. So much is certainly valid in the case of formal verification, where good methodologies require a small set of tool licenses, and methodologies provide a quicker turnaround on proof results, yielding an optimal use of the compute cluster. So I have, over the period of last 2.5 years, described numerous case studies where we have demonstrated that we are able to find corner case bugs and build proofs of bug absence on very small machines. So a tablet PC with merely 8 GB of RAM, with a couple of CPU cores, one license. We can use it to verify serial devices, microprocessors, you name it. I have not felt that much challenged by the size of the machine. But of course, when the designs become bigger and you have lots more concurrency and control, you might want to go to the next size of the machine. But I'll tell you honestly, that isn't the main reason why you should consider not adopting formal. Let's talk about debug, right? So what is the most efficient strategy for debug? And there are numerous challenges in adopting debug. Different debuggers work slightly differently. But for formal verification, the differences across different tool offerings for debuggers is not that significant. And it's the way where formal verification actually works. It tries to get you the shortest path to the bug most often. So it's renowned to have very small, short bug traces. And typically, if you compare them with simulation or emulation test. So I would argue that actually using formal for debug is a lot more efficient than using other verification techniques. I recall in one project when I was investigating a bug in an SoC controller, one of the performance counters were not behaving properly. The error was flagged by a highly competent verification engineer who had spent 3 weeks debugging the emulation trace to find that actually there was a buggy counter. Now, of course, having 64-bit counter in your design can be quite painful because neither in simulation nor in most formal environments you can actually get the counters to cover the entire state space. So for a 64-bit counter, we're talking about 18.4 quintillion states. So not million, not billion, not trillion, not quadrillion, but quintillion. And that's a lot of states. So what we do is then in formal, we can ask a question in a way that allows us to find these kind of bugs, even in a counter as big as 512 bits in a minute. And regardless of the type of the bug, we can always reproduce the buggy trace in a minute. So I'll take that, right? So formal verification bug traces can be extremely small depending on how you actually approach the problem. Let's talk about factor number 6, which is bug fix and retest. How easy is it to fix a bug? How easy is it to test that a fix works and that has not broken anything else in the design? Fixing one bug and thereby causing another, this is a long-standing problem. The cool thing about formal verification, especially for bug fixing analysis, is because formal is exhaustive and the nature of algorithms is such, you are able to not only verify, establish that your bug was fixed properly, you can also prove that it did not break anything else, that you haven't introduced new bugs in the design. So I would argue that formal verification for bug fixing is a great idea. Let's talk about sign-off. What time, effort, and engineering resources are required to be sure that sign-off is complete? I did talk about coverage 2 weeks ago about formal verification and coverage. So I would recommend you go and listen to the podcast if you haven't actually done that already. But let me make a more general discussion around sign-off here. So understanding what it costs to sign-off verification is a topic in itself. But we can get a high-level idea by looking at those factors above and how they contribute to a coverage-based sign-off infrastructure. None of these factors should be only considered in silo. So even formal verification has a cost and it's not entirely free. For example, stimulus generation is free for formal, but still you have to spend time in understanding your constraints and not blocking out good stimulus. So provided you use the right coverage techniques, and in our podcast on Have You Got It Covered, we talked about some of these, formal verification sign-off will become a lot easier. And tools are offering great solutions for sign-off in a way that saves engineers an enormous amount of time. And one of my favorite technique is mutation-based coverage. So if you want to know more about it, feel free to go and listen to our podcast from 2 weeks ago. The important thing to note is that when one is able to prove a property exhaustively with formal, establish at the same time that the free formal stimulus was not blocked by user-defined constraints. Okay, so understanding what aspect of input stimulus was blocked by your constraints and understanding what checkers were checking and checking what is the important point to understand. and obtaining coverage results from your cover properties. Together, all of these things build you a more complete, well-rounded picture. Let's talk about late and missed bugs. So I talked about it in the beginning of the podcast today. What would it cost if a bug were found 2 weeks before tape out? What would it cost to patch a broken chip if a bug were to escape into the final product? Now, putting these risks in another context, what if we could have found the same bug in the first hour of design bring up? We still do not really know how much it has cost us to fix Meltdown and Spectre, or the numerous other security holes that emerged in the last 2 years. I would argue that if you were using formal verification earlier in the design cycle and maintain a systematic deployment flow across all of the IPs, it would minimize the chances of leaking out these security holes. Our own work in the context of RISC-V processors has shown that just the application of automated functional formal verification through our RISC-V proofgate can identify architectural security holes, micro-architectural security holes in processors. And some of these were not even found by simulation, even though simulation was applied much earlier than formal on these designs. So it is a great technique that you should consider deploying if you were worried about security and hardware. Let's talk about reuse, factor number 9. What options are there to reuse the verification infrastructure? So you want to minimize the costs related to your engineering resources and shrink your time to market. Architecting end-to-end formal verification test benches does require an investment of time. And for big designs involves dedicated deployment of engineering resources. Let's not run away from any of these facts. But the good news is that if this effort is properly planned for, based again on good training and a good methodology, it is very likely that the test bench can be reused. So where formal verification wins over simulation is that formal does not require any investment in stimulus generation. I think I may have repeated this already a few times in the podcast today. And it can be deployed across the I/O boundary of the IP as well as on internal finite state machines for detecting and proving exhaustively that the designs are free from deadlocks and live logs. So what I'm saying here is it can be done end-to-end, it can be done on the internal signals of the design so that you can actually root cause the source of the bugs much more quickly, and also insert these monitors in formal that could be reused in simulation. So any investment you're making in this methodology and flow deployment would yield ROI consistently going upwards, even in simulation and emulation. So let's talk about the last factor, shall we? So engineering resources. How do you maximize productivity across your team? If a junior engineer finds most bugs in a project, surely that is much more cost effective than having a principal engineer do so. No offense to the principal engineers out there, I was one myself. But I remember from my experiences at several major companies, and even today when I work with clients, the best resources for formal verification are often the youngest hires. But again, with the caveat that they have received adequate training and they know what they're doing. I can, of course, think of several star performers who went from initial training to production grade work in weeks and have continued to use formal verification ever since. The reason why formal verification is easier to learn than, for example, constrained random is because all it takes to become productive is some background in digital design, familiarity with some high-level design languages like Verilog or VHDL, and a problem-solving mindset focused on requirements as the basis for verification. So it's extremely simple in what you need to get started. You do not need to be good at understanding polymorphism, object-oriented programming, software engineering. All of that is not required to learn formal. So time to invest in formal? I urge you to consider your verification choices carefully. History is an important asset. So analyze your previous project data. It should reveal what worked for you without formal and what did not. Be honest about it. If you use formal and it did not work, do you know why? Perhaps we can come and help you identify what did not work for you. Maybe we can help it make it better for you. Was part of the problem down to a lack of good training and or methodology? Do you need formal verification is my final question to you. And you know my answer. What is yours? Perhaps you may agree with some of my reasons to use formal, perhaps you don't. In any case, get in touch and share your thoughts. Go subscribe to our YouTube channel if you haven't done that. and we will be back next week. Stay connected.